Okay, so what you see, what you see on the board. What you see on the board here. Obviously graphs. We're going to go through a couple notes today, and then my goal is to, once we're through the notes, you're done for the day. Done early, no homework, nothing like that. You've already had enough homework this week. So, now, because we did an in-class activity yesterday. Now, here's the thing.
On sale at Firebox.
Okay, here's the thing. On Tuesday next week, I warned you of this, you're going to have about 5 teachers in here watching the activity that day. They're not watching you, they're watching the activity we're doing. I'm going to explain the activity right now so you get kind of familiar with it. It's based on red cards. You can see them over there. They'll be a different color. I'm picking whatever paper I have left. But what you're going to have. So, on Monday, you're going to have an exit ticket. Okay? Here's the goal on your exit ticket. Obviously, you want to do as best you can because I'm going to be breaking you up into groups based on your exit ticket. It's based on what type of problems you're not comfortable with, which ones you need more help on. So just try your best. That's all I care about. It's got, I think the exit ticket will have 6 or 7 problems on it. Okay, just to kind of see where you're sitting with the problems we've done and what we're doing today. Okay, because obviously Monday will continue on, right? So we're going to do that. Now, on Tuesday, when you walk in here, here's what you're going to see. You're going to see a bunch of desks around the outside of the room, the outside 4 walls. They're going to be pointing at walls, okay? There'll be a couple up here, left, right, and on the right. In the middle, you're going to have a bunch of desks in the middle of the room. So, it's going to be pretty straightforward. When you walk in, I'm going to tell you where you should start. Okay, so I'll have maybe a seating chart on the board, and it will point you to a direction of the room that you're going to be sitting or standing in. Now, there will be more than a few desks. I'm just putting a line there to represent where the desks are. Okay, your goal, obviously, is to try some of those problems that are in the board in front of you. I'll have a bunch, so if there's some up here, I may have 6 or 7 problems up here. Your goal is to try, I think I had set out like 4. Okay? Then you're going to move on to the next group. And I will tell you which group you're going to move to. Does that make sense? So, you may not move in counterclockwise order. You might go from this group to this group. Okay? Because I'm going to change up the order of the groups you're going to do. So every time you're done with your 4 problems, and I'll have the answers, because when you pick up your card, you'll be able to see if you did it right or wrong. Okay? That's what's going to be on the back. They might not be red, but you get the idea. Don't cheat, just try the problem legitimately out. If you get it wrong, try a different problem, but I want you to get at least 4, then you move it on to the next problems. But you got to check back with me when you're done. So you'll have to have a piece of paper, some graph paper. I'll provide you both Monday if you need it. And then you're going to check with me after you got your 4 done. I want to see how you did, what you did for it. And then I will tell you what group you're going to go to next. Does that make sense? Your goal is to get through all the groups. Okay? And when you're done, your goal is to go to the middle of the room when you're all finished with the problems I have you working on, and then you can work on the homework that I'm going to assign that day. Okay? Does that make sense? It's kind of a weird activity where we're practicing problems so that you're ready to actually go attempt them yourself. So you get like kind of one-on-one experience. Now, at any point during this activity, if you have a question, like you're looking at a problem, like you're looking at all the problems that are in front of you, whatever side of the room you're on, and you're like, you know what, I have no idea even how to attempt this problem, like any of them. Then you're always allowed to come to the middle of the room, wherever you're at, and I'll be here, and you can work with me one-on-one on the problem that you're working on. Does that make sense? So don't feel like you're stuck. Come in the middle, we'll work on a problem or 2, and then I'll send you back to the group and you try to finish up your problems. Okay, because I want you to try to get like individual help on the style of problem. They're very individual style problems. Differential quotients, graphing, looking at max and mins and intervals, looking at linear equations. They're very distinct style problems. But that's the problems we're doing. Okay? Does that make sense, the activity?
Pretty elaborate for a 20 by 20 room.
Yeah, it works out pretty good. I tried it with algebra to see kind of like the actual like order and how it works.
1A.
It's pretty, yeah, and they liked it. So it was pretty smooth the way that it worked out. But just ignore the 5 teachers that are in the room. Like seriously, ignore them. They're not actually watching you. They just want to see the interaction, like how the class works, how like you rotate the room, how you're trying different problems out. Just ignore them. They're going to probably take notes. I'm expecting Weidenstein's in here. She'll probably be trying some of those problems out herself because that's what she does. So just kind of ignore that. That's Tuesday coming up. I want to give you a fair warning of what you're doing that day, so you're not like lost. You're like, oh my god, I have no idea what you're talking about. I'll try to warn you of this on Monday again, okay? So you kind of know what you're doing.
Now,
Okay.
I believe he said Bumgard would be in here?
Yeah.
Yeah.
All right.
We'll see him trying somehow.
Oh gosh, the tongue out.
All right. But that's coming up
He's
Tuesday.
trying to
Now,
add the homework
hey,
problems.
here's the idea. The new stuff today. This new stuff is a part of the homework you're eventually getting. This is a part of the new stuff we're getting. Now, obviously, we've been doing piecewise functions. We've been doing differential quotients, max and mins, domain and range, intervals, rising and falling. What we want to do today is linear equations. Just stick with the linear stuff. No curves, nothing like that. We are eventually going to see a lot of curves in chapter 2. I showed you hints of how to do it the other day when you were just plugging in random numbers for linear equations. Today we're no longer just guessing and checking numbers. Okay? So here's the types I would like you to write down. So number 1. Stop. Now,
What'd you do? The eraser and the...
first one. Let's go point slope form.
Don't do it. Nice shot.
Okay, point slope form. This is the first type. This is going to be the types of linear equations. So when I look at that equation, I know how to go draw it or how to take information and go to that form. That's one type of linear equation. Second type today that we're going to talk about, that I want to discuss, is slope-intercept. This is the go-to version for all Algebra 1. That's another one we're going to focus on today. The third type is called standard form. That's the form that you use a lot in Algebra 2. Standard form is like when you're doing systems of equations, where you're stacking like elimination method and substitution method. That was the method they used. It's not really great for graphing. It's really good for like story problems. The fourth type is called general form. And that's a form, I don't know if you've used too much, or you even know what it is. Our goal today is to introduce these forms, give you kind of an example of each, and then we're done today. That's it, 4 problems. Okay, does that make sense? Monday, yep. So Monday we're going to continue this, that way you get a sense for it, and then on Tuesday, I basically mixed kind of all the problems that we've done in the last couple sections, and we just kind of put them into one. And then your assignment that you're going to get is mostly based on these. There might be a few things you have to do like domain and range, intervals, that kind of thing. But
So you're going to put us in groups with people that also suck at whatever we suck at?
no, it's literally just broken up into problems that you need to work on. That from that exit ticket that you showed that maybe you're not proficient at it yet. Not that you suck. It's just maybe you're just not. Maybe you didn't have even time to finish it. So because I'm going to give it the last couple minutes of class, so I don't know where you're sitting. If you're gone Monday. Sorry, you're going to be thrown into a group at random. Maybe it might be a problem you're really good at. Sorry, you just weren't here, so I didn't have data.
I see. We're going to
So,
try to sit in the corner.
all right.
Sit there.
All right, now, and here's the problem. There may be groups that maybe you don't even have to work on that. You'll work on a different group. So there's a lot of semantics stuff that I iron out over the weekend to see how that's going to work for you guys. Because Algebra 1, it works because everything kind of flows together, but you guys are doing very wide topics. So, all right, now for you guys, let's go through an example of each type so you understand what it is, what it looks like, and then we're done today. Does that make sense? Okay, so here we go. First type. Does anyone still need these, or do you have them written down?
I got them written down.
Everyone's got them?
Yup.
Oh, yeah. Yeah.
Okay, all right. I'll put them back up one at a time, but we're going to do one step at a time. So here we go. First type. Okay, first type is called Pointslope Form. If you're not familiar with this form, here it is. This is the first type. This is what it looks like. I know it's going to seem kind of odd. That's the formula you're going to need. Now, obviously on test day or quiz day, whatever we have, in this chapter coming up, probably in a week or two. That's kind of one, because we're almost near the end of the chapter 1. I mean, there's not a lot of sections in it. What we need to be cautious of, you need to know your formulas. I will have them on the board. They'll be kind of on the board probably over here on that side. I don't know what side I'm going to put on because geometry's got all their volume and area formulas I'm going to need to put. Now, here's the idea. On this particular section, on this style, what you need to know, this is slope. Okay, it's obvious they always use M for slope. And then the x1 and y1, these two numbers, That's a coordinate that you're passing through. It's the coordinate you're passing through. Notice, you are always subtracting x1 and y1, no matter what the numbers are. Now, I'm going to give you an example, and then we're going to go and see how that works. So, here's how I'd like you to, if you're drawing stuff in your notes, try to draw a graph that looks like this.
What are you doing, Brady, come on. Let's start, Brady.
Stop talking. All right, so here's my first example. I give you a graph. Now, why we have this form, why we have Pointslope Form. This form is really great if you have data, you have some type of information. You either have a graph or you have coordinates. In my case, I have both, as you can see it. If I have data and I want to come up with a formula that represents the data. So like on a business model, you have all these sale numbers over the last couple months. Now what we can do is we can associate an actual like linear equation to that data so you can see where your trend's going. The reason why, you can project what you're going to need later. That's why this is actually helpful. Now this is linear. It's like, why you'd ever do this? Because I know data in like business is messy, it goes up and down a lot. This is kind of like what we use for a best fit line. Something that goes right through the middle of all of your scattered data, so you can kind of see the overall projection of where you're going. So maybe you need to buy more products. Maybe you need to hire more employees because of the sales numbers that are coming, or maybe you need to let go of employees because you're losing profits because you have too many employees. Like that's something you need to think about. Now, we go through the data here. Obviously, slope is rise over run. Most people count with their fingers. They go, okay, I'm going up 2 over 1, up 2 over 1. You can do that. You could do the old-fashioned thing where you actually subtract, the x's and you subtract the y's. That was the thing they teach in Algebra 1 and Algebra 2. I don't really mind how you do it as long as you're getting the right slope. The rise is on the top, that's your y numbers. X's are the run numbers. So in my case, my slope is 2 over 1. I'm rising 2, running 1, and it's going to the right. It is a positive slope. I can prove that because any of the coordinates I picked. One of the coordinates was 2, 2. The other coordinate I had was 3, 4. And when I actually subtract these, and I plug them into the formula, I have to subtract the y numbers on the top and the x numbers on the bottom. And you'll actually see it is 2 over 1, like positive 2 over 1. Now, the x1 and y1, it's the coordinates you pick. You can pick any coordinate up there that I'm passing through. So I'll just pick one at random. I'm going to pick this little guy right here. I just picked that one. It's anything that's on your data for that graph. So in that case, that one is 5, 8. That's the data way up there. So so this number is 5, 8. And so I'm going to plug the 5 in here and the 8 in here, and yes, you'll always subtract whatever that number is. Even if it's a negative, you will subtract the negative number. Questions on that first type? Does that make sense, like what we use it for, though? You can take data and go from there. Now, did I pick a wrong coordinate? I think it was 5, right? It was 5, 8. Okay, we're good?
Great, so what do you do with that?
So now that I have this equation, now I can project what I'll need later. So like now I can pick any x number. I can pick 20 down the road because I can't see where 20 is going to be. I can plug in 20 and it'll spit out a y number. It'll tell me what my sales numbers will be 20 months down the road. That's why it's nice. I have an equation that I can use to project. Or maybe I want to know when will I hit 100 sales. I can plug 100 here and then it'll tell me how many months I'll need to get to that point. So it's kind of nice to see that projection. Okay, are we good on the first one? Now notice, it's linear. There's no powers here. No powers at all. Okay, second type, here we go. Again, I'm going to go through these pretty quick. Hopefully you're kind of paying attention here. All right, second type. It's the second type, SlopeIntercept Form. Okay, SlopeIntercept Form is when you have an equation, you rearrange the equation so it looks like this. So you have some type of data for your business, because you've had coordinates and you've had numbers. You had no graph, but you've taken the data and you've actually come up with a formula for it. Now, if you rearrange it to this form, I can go draw it now. I can now give you a visual aid that goes with the data that your business was spitting out. Now, I know some people could just go plot the data, but this will give you a very nice, clean, linear line to it. So if you had that last equation that I just showed you a little bit ago, I could have rearranged it to this one. So this form, this is slope. This is the y-intercept. That's where it hits the y-axis. Well, that's the only two numbers that I need. So no matter what equation I have, so, you know, if I had some goofy equation like this, I'll just give you the last one I just did. 2x minus 5. So this is the last equation I just showed you, right? We could rearrange that equation to get it to look like that one. Because all I need to do is get the y by itself. If the y is by itself, that's what the form should look like. So I'm going to distribute, I'll distribute the power of 2, or sorry, just distribute the 2, I should say. So that's 2x minus 10. So I distribute the 2. And then I'm going to add the 8 across. So I'm going to add the 8 over. So here's what I get. I get 2x. If I add the 8 over, negative 10 plus 8 is negative 2. This is the equation now that I can use to go graph. And it'll look like just the last picture I had. I know my slope. This is my slope. It's 2 over 1. That's my slope. This is my y-intercept. My b number is a negative 2. Yes, you have to keep track of the negative sign there. So that means I'm going to start at negative 2 on the y-axis. That's what it means. That's my y number, right? It's negative 2. And my slope tells me to rise 2 and run 1 from there. It's always going to the right, up and to the right. Question?
What would happen if the bottom number, like what would it look like if the bottom number was a different number?
Like 4 or 10?
Yeah.
So you'd rise 2 and run 10.
Yeah, but how would the equation look?
So if this was like a 10, let's say, 2 over 10. So maybe you have to divide everything. Maybe there's a 10 here, you have to divide everything by 10. Maybe that's what it was. My case is a 2. 2. Okay, yeah, we'll get them through more examples like that. That'll be like the next one we do. We'll see that. All right, so what we have is we have my slope, and we have my y number. So my y number is negative 2. I'm going to rise 2, run 1, rise 2, run 1, rise 2, run 1, rise 2, run 1. And it's the same graph I just showed you. Now it's just extending further. Now I can go back further on that because I can use my slope. Questions on that form? It's the go-to version, why they use it in Algebra 1, to draw pictures. That's why we have it. Questions on that? Okay, now, the third form, and this will answer your question, Sarah, that you had. The third form is called standard. Now, standard's really good for like a story-based problem, so I'm just going to give you the example of what we have here. So standard form would be, so standard form is ax plus by equals c. Okay? So that's the version. Now, what all these numbers are, A, B, and C's. A, B's, and C's, what they say in the book, A's, B's, and C's belong to, that's the little e, belong to, and what they usually say is they say the integers. So they have a z in the book. And what that means, I can have positive, negative numbers. We prefer that they're not decimals and they're not fractions. That's what an integer is. It's positive or negative, whole numbers, natural numbers, no decimals. So if you had a problem that had decimals, you'd want to get rid of it. So like for instance, if I had a 10x plus 0.2y equals 20, like that was my problem, probably what I want to do is multiply everything by 10 one more time. That way, if I multiply everything by 10, it gets rid of the decimal point. That's what multiplying by 10 does. It literally just moves a decimal over. That's what powers of 10s do. Now, why I would do that? This is easier to draw. This is easier to draw than having decimals and you're trying to figure out how to draw that in a graph. Now, how you'd actually attempt this, how you'd actually go about this, you have to rearrange it to another form. Now, what this data would represent, like what a story problem could be, you went to a grocery store, you bought 100 candy bars, you bought 2 cans of soda, and you spent $200. That type of thing. So maybe the candy bars were, maybe the candy bars were, I don't know, $1.50, and the cans of pop were more than that. So, or it could be anything. I mean, this could be the number of people. Maybe there's 100 males in a concert and 2 females, and there's a total of 200 people. Well, Or maybe it's like objects that they're bringing, well, how many total do they have? You know, how many items do they have? How much do they pay per ticket? And this is the price of all the tickets put together. That type of thing. Like it could represent any type of story problem as long as you understand you have different categories and this is your total that you get in the end. So that's why they use an algebra 2 a lot. And when they do like, when they do systems. Now, if I was gonna graph this thing, just like Sarah, you were asking earlier, I would have to move the 100x over so it would become negative, right? Because when it moves across equal sign, it becomes negative. And then on this one, I'll have to divide by 2. And so now you'll have a 2 on the bottom. Now I know you can simplify that, but this is literally what it would look like. Okay? And you could go graph. This would be my slope, that'd be the y number. And I would divide those numbers out, figure where they go. Now maybe this is, obviously this is the number 100, so I start at 100 way up. This is going up, or going down 100 and over 2, down 100 over 2, or it's down 50 over 1, however you want to think of it. Questions on standard. Typically standard, we'll see this, maybe chapter 7, we'll come back to that. We really don't see it until about chapter 7. That's really one of the last sections we do in the end of the year. We start doing systems, because we'll do systems for 3-dimensional objects. And we'll do matrices and stuff that you've done in algebra 2. So, we'll do stuff that I don't think you've ever attempted before for algebra 2. So, we just kind of extend it further. All right, questions on standard. Okay, the last form, this is my last problem of the day, and then we're done. Last problem. We're going to look at what they call general form. Okay, so general form. Let's see, where's my keyboard sitting there? There we go. Okay, so general form. Okay, so general form looks like this. AX plus BY plus D equals 0. Now, you're probably thinking, okay, why would we have that? It looks like standard form. It looks like the only difference is there's a 0 on the one side. Why you'd ever do general form is when you factor. So when we did problems, you know, what, the last chapter test we took, we had problems like this. And you had to go factor that thing apart, right? What you wrote down there, I just didn't tell you, that is general form. Because you have a 0 on the one side of the equation. No matter if it has powers or not, that is still considered to be general form of a polynomial. Okay? So yeah, so why we ever do general form is so you can actually factor apart and find x-intercepts. That's why we do factoring. It's where it's at the actual x-axis. Now in our cases, since we're doing linear, this is a curve, so it would hit the x-axis twice, potentially. On ours, if we're doing linear, you'd have to rearrange to another form to figure out how to draw it. I go to SlopeIntercept. But there's such a thing as general form. Questions at all? Okay, we're done for the day. That's it. So I know some of you guys got tests today. If you owe me homework, some form of homework, I should be working on it. I'm going to hand out some papers. So, papers to hand out, you can always make fixes, turn them back in. You guys know the drill.
Hey, Ward.
What's up?